watch all of the exciting things that NASA is doing. And I'll tell you, we have to remember that NASA has an amazing ability to do stunning achievements even in the midst of difficult times. And you can see I'm in my living room in the midst of the coronavirus pandemic. I know all of us have been working overtime, working from home, working with our children in many cases out of school. And it's been a challenge, and we all know that. But this mission was one of two missions that we protected to make sure that we were going to be able to launch in July. And the reason that's important is because of the alignment. When you talk about Earth and Mars being on the same side of the sun, that happens once over 26 months. So it's very expensive if we have to take Perseverance and put it back into storage for a period of 2 years. It could cost $500 million. And so this is an important mission for a whole host of reasons. But what I really hope is that people watch this mission and that they are inspired, that we know that we can strive and achieve even in the midst of very challenging times. And so I think that's important. Alex Mather, a 7th grader in Northern Virginia, actually named this little robot. I should say big robot. We're talking about something the size of an SUV. But he named it Perseverance. And I think right now more than ever, that name is so important. And I just want to thank Alex for giving us that name because we are persevering and we are achieving even in the midst of these very challenging times. And I also want to say that, we're talking about Mars today. We have a big agenda. We have been given a directive to go to Mars with humans. And in order to achieve that, we're doing two things. Number one, we're building an architecture at the moon where humans are going to be able to sustain for long periods of time. And we're doing that under our program called Artemis. The other thing that we're doing is we're moving forward rapidly with these very important Mars robotic precursor missions so that one day when we send humans to Mars, we're going to know where to go to get the absolute best science and data that we can get. And it's not lost on me that 51 years ago on July 20th, I mean, this is important, 51 years ago on July 20th, Neil Armstrong and Buzz Aldrin were walking on the moon for the first time in history. And during that time, they did the first ever lunar return mission. And here we are with Mars Perseverance, 51 years later, getting ready to do the first ever Mars return mission. So these, I think, are important milestones. We've done it with the moon. Now we're going to do it with Mars. Perseverance is the first step in an eventual return of those samples. But I'll tell you, the thing that has me the most excited as the NASA administrator is getting ready to watch a helicopter fly on another world. That's something that's never been done before in human history. And here we are getting ready to launch Mars Perseverance with Ingenuity, its little helicopter, strapped to it. I am very excited about watching a helicopter fly in another world for the first time in human history. And I know there's a great panel. You're going to hear great things about all of these different experiments and technology demonstrations that we have upcoming, but we're very excited about Mars Perseverance, and it's a great time to be at NASA, and I hope it's a great time for everybody to watch the stunning things that NASA is capable of doing. So with that, Raquel, I'll turn it back to you.
Thanks, Jim. It really is an exciting first step. And for anyone watching who would like to submit a question, you can do so now by using the Ask NASA hashtag. Our phone lines are now open to the media, and you can ask a question by pressing *1. And up next, Planetary Science Division Director Lori Glaze will talk about how the Perseverance rover advances NASA's exploration of Mars.
Thanks, Raquel. It is my pleasure to be here today as we begin our countdown to Mars and the launch of the Perseverance rover. At NASA, our vision for science is to lead a globally interconnected program of discovery that encourages innovation, positively impacts people's lives, and is a source of inspiration. And this mission does all of that. Perseverance is the most sophisticated mission we've ever sent to the red planet's surface. It's the next step in our historic Mars exploration program, which has been exploring Mars and unlocking its secrets for decades. And we couldn't be more excited about it. Some of Perseverance's main activities will be in astrobiology, which is the study of how life comes to be, the environments that can support life, and the search to see if life exists anywhere else beyond Earth. This is the first rover mission designed to seek signs of past microbial life by collecting and caching rock and soil samples that will be returned to Earth by future missions. The rover's instruments will also look for evidence of ancient habitable environments and monitor environmental conditions, which will help us better understand how to protect future human explorers. The rover will study the record that is preserved in the layers of rock on the surface of Mars, looking for those rocks that formed in water and could have preserved evidence of the chemical building blocks of life. The rover will also demonstrate a key technology for using natural resources in the Martian environment for life support and fuel, like producing oxygen from the carbon dioxide in the Martian atmosphere. Its landing technology and environmental sensors will also help inform future human missions to Mars. And just as Perseverance builds on past missions, it's also the first step in the first ever round-trip mission to another planet in our solar system. Scientists have wanted a sample of Mars to study for generations. We have meteorites on Earth that came from Mars, but it's not the same as getting an actual sample of pristine Mars rocks and soil to study. And now, we're at a point where we can begin to attempt this amazing feat. Samples from Mars have the potential to profoundly change our understanding of the origin, evolution, and distribution of life on Earth and elsewhere in the solar system. Even now, NASA continues to study moon samples brought back by the Apollo program more than 50 years ago. We expect samples of the red planet to provide new knowledge for decades to come as we study them with state-of-the-art laboratory equipment we couldn't possibly take to Mars right now. The plan for Mars sample return is multifaceted and complex. This historic feat requires multiple spacecraft and our partners at the European Space Agency working together in a synchronized manner. Let me show you how. First, Perseverance is going to drill and prepare samples for return and cache them on the surface of Mars. In 2026, a fetch rover will be launched to collect those samples and bring them to a rocket that will launch them into orbit around Mars. Another orbiter will rendezvous and capture those samples for safe delivery to Earth. If it sounds complicated, it is. The technology to return the samples that Perseverance collects is maturing, but NASA's investments in developing autonomous robots and landing large payloads on Mars have laid the groundwork for a successful sample return campaign. We are thrilled to be working with the European Space Agency on Mars sample return and partners from Spain, Norway, and France on Perseverance science as we take our next steps in exploring the solar system. So, you probably want to know more about how Perseverance is going to accomplish its mission. And for that, Katie Stack-Morgan from NASA's Jet Propulsion Laboratory is going to talk about our landing site, which is a really special place on Mars.
Thanks so much, Lori. So in just 1 month's time, Perseverance will begin its journey to Mars, specifically Jezero, a crater located on the inner rim of one of the largest and oldest impact basins on the surface of Mars, which you can see in this inset here. At Jezero, we'll have access to some of the oldest rocks in the solar system, between 3.5 and 4 billion years old, as well as a record of diverse geologic processes, including volcanism, impact cratering, as well as processes associated with water, both at the surface and subsurface, that can tell us about how the planet evolved over time. We also think that Jezero was home to a variety of different potential habitable environments where Perseverance can begin its search for the signs of ancient life on Mars. Specifically, Jezero is host to one of the best preserved deltas on the surface of Mars. Deltas form when rivers enter open bodies of water and deposit rocks, sand, and potentially organic carbon in the layers of that delta. Those layers are one of the prime astrobiology targets for the Perseverance mission. Also in Jezero, we see carbonate minerals around the inner rim of the crater. Carbonates can form in shallow lake margin environments, and based on what we know about carbonates here on Earth, we think those are another really important potential astrobiology target for the mission. We'll also have a chance to explore the crater rim, which exposes some of those oldest rocks in the field site, as well as some potential habitable environments that might have formed as a result of that impact event itself. At each one of these locations that Perseverance will explore, we'll be searching for biosignatures, patterns, textures, or substances that require the influence of life to form. Now, we don't know for sure what biosignatures on Mars are going to look like, but we can look to our own Earth rock record to give us an example of what we might expect to find. What you see here is a 3.4 billion year old rock from Australia called a stromatolite, which is a fossilized microbial mat. Each one of these layers that you see in the rock represents the growth of that mat over time. Now, if you look at that rock, you wouldn't know for sure that it was a potential biosignature. But when you couple the textures, as well as the chemical composition, the mineralogy, and the distribution of organic carbon, you can start to build a case that that rock could only have formed under the influence of life. Now, this is exactly the type of thing that we do here on Earth to make a case for biosignatures in our own rock record, and for the very first time using our instruments, we can do that on the surface of Mars. So using that fine-scale detail, coupled with the geologic context, we're going to do our best to identify, collect, and document the most compelling scientific cache of samples that we possibly can to address some big picture questions, fundamental questions, including, how did the surface and climate of Mars evolve over time? How do rocky planets form and differentiate? And of course, was life ever present on Mars? To accomplish this, we're going to use a scientific payload of 7 instruments. Some of those instruments, like the Sherlock and Pixel instruments on the end of the rover's arm, which provide those mapping capabilities, as well as RIMFAX in the body of the rover that uses radar to study the subsurface of Mars, are brand new. We've never sent them to Mars before. Other instruments, like the SuperCam instrument and MassCam-Z up on the mast of the rover, are updated versions of instruments that we flew on Curiosity. These instruments represent contributions from the U.S. and our international collaborators, and are uniquely well suited for helping Mars 2020 accomplish its science objectives. As a part of that, we're preparing for future human exploration of Mars, and to do that, we're using instruments like the MOXIE instrument, which takes CO2 from the Martian atmosphere, converts it to oxygen, which is relevant for life support and potential creation of a fuel that could get those astronauts back home to Earth. We also have the META instrument, which is our weather package that measures pressure, temperature, and humidity, which are pieces of information that astronauts would want to know if they wanted to work and live safely on Mars. So we're still 8 months away from Perseverance landing on the surface of Mars, but our science team is busy at work prioritizing our most important science questions, trying to figure out where we would go with Perseverance to answer those questions, and thinking about what samples we want to put in our sample cache. And we can't wait to get Perseverance to the surface of Mars. And so with that, I'll hand things over to our Deputy Project Manager, Matt Wallace, who'll tell us a little bit more about the engineering side of Perseverance and share with you some of the challenges that our team has had to overcome over these past few months.
Thanks very much, Katie. Perseverance is a big 1 metric ton vehicle, as the administrator said. It's a very capable system. At first glance, it looks a little bit like the Curiosity vehicle, and in fact, we have been able to leverage a lot of the investment that was made to bring Curiosity to the surface. In particular, the entry, descent, and landing system has some commonality. However, this vehicle is in fact a new mission, a new vehicle with new capabilities. Katie talked about some of these enhanced instrumentation, which we're taking with us, and technology experiments. I'll mention a couple of the engineering systems. Starting with the wheels at the bottom of the vehicle. There's 6 wheels, and they've been ruggedized so that they're more capable of dealing with the surface of Mars and pretty much anything that Jezero crater can throw at us. Also, we have a new powerful computer that we've added. It's doing double duty. In fact, its first task is to help us get safely down onto the surface of the planet. It's taking imagery of the surface during the descent activity, and processing that imagery and figuring out where we are in Jezero, understanding relative to the different hazards in the crater, and it will divert the spacecraft away from those hazards. Now, Jezero is a very interesting scientific target. It's got a lot of relief, rocks, cliffs, hills, things like that, which are great for science, but they are also challenging for landing a spacecraft on Mars. And so this new system will keep us safe in going to this exciting new science target at Jezero Crater. We also use this computer to help us process imagery on the surface more rapidly. And by doing that, we can look for hazards and we can avoid those hazards as we're traversing, doing our science mission. That allows us to drive at about twice the speed that Curiosity was able to drive, in fact. In addition to the computer, we have some new cameras. Now all our missions carry a lot of science and engineering cameras to begin with, but we have something new this time. We've taken some ruggedized commercial cameras and we've dispensed them around the spacecraft, and those cameras will be taking high-definition video of the spacecraft during the entry, descent, and landing activity. So we should be able to watch this big parachute inflate supersonically. We should be able to watch the rover deploy and touch down on the surface. And this is going to be very exciting. It's the first time that we have ever been able to see a spacecraft land on another planet. We're looking forward to that imagery, obviously. We take a lot of cameras with us to the surface of Mars, and we have, again, on previous missions, a lot of eyes, but we've never taken ears. And so this time we're also taking a microphone, a couple microphones actually. And again, those microphones will be active during the entry, descent, and landing activity. We should be able to hear this system as it's going through the process of actually landing on Mars. And then when we get on Mars, we'll also be able to turn on the microphone, listen to the wheels turn over the surface on the rocks, listen to our big rotary percussive drill out on the end of the robot arm, sample those rocks, as well as wind and other things. And so those are all exciting new capabilities that we have on the vehicle. You don't get through development of this complexity without a few problems, and I'll just mention a couple. I'll start with a couple years ago, due to an anomaly on a parachute test program, we had to take a second look at our own parachute and the design that we had for that parachute. And we made the difficult decision to actually modify that parachute to strengthen the canopy, to give us more robustness during that supersonic entry activity. And that is not an easy thing to do, in part because you have to test this parachute. And testing parachutes on Earth is difficult. You have to put it on a sounding rocket, which we did out of Wallops facility down in Southern Virginia. You take them up to the upper atmosphere, and then you deploy these parachutes in the thin upper atmosphere to simulate the Martian environment. And what you're seeing here is a slow motion video of one of those parachutes inflating. And in fact, these are difficult tests to do. This is the first supersonic planetary parachute test that we've done in about 40 years for the agency. And the project was fortunate and able to pull off 3 pretty much perfect tests. And so that was one of the challenges we had. And Katie mentioned, and others mentioned, the sampling system that we have on the vehicle. Our sampling system is, of course, composed of a lot of different mechanisms that we use to move the robot arm, to core the sample, and then to manipulate and seal the sample after we've collected it. And it's very difficult to build mechanisms for a rover that has to operate flawlessly 100 million miles away with no human intervention. And so building those gearboxes and those motors in an environment that drops down to minus 200 degrees Fahrenheit pretty much every night, that's exposed to this very fine Martian dust and has to deal with other adverse environments is always a challenge. Our sampling system was particularly challenging in that we also had to keep it very, very clean. In fact, this is probably the cleanest system that we've ever launched to Mars. And the reason we needed to do that is that the science community, as you just heard, is looking for trace signatures from billions of years ago, trace chemical signatures. We don't want to confuse the search for those ancient signs of life with terrestrial contamination that we took with us to Mars and then, of course, brought back. And so that required a lot of effort to understand how to get this system both biologically and chemically as clean as we needed it. So those are some of the challenges. Some of those kind of come along with the territory, but I will say a few months ago we were faced with something we really never expected, as was the rest of our community and the rest of the country and the world, and that's the pandemic. It really began to affect us in mid-March. We were at a critical time in the processing for the spacecraft. All the elements were down at Kennedy Space Center, and we had to fully assemble and do the final testing of the spacecraft. It had to be done right. You can't make a mistake at that point. And of course, the environment made that a lot more difficult. So I think we have a short video here to talk a little bit about some of that final processing and how we approach those challenges relative to the COVID-19 situation.
This new rover will search for signs of ancient life, test new technologies, and gather rock samples which may someday become the first pieces of the red planet ever returned to Earth for analysis.
Today we are naming a spacecraft that will go to Mars, and the name is Perseverance!
When Perseverance was first selected, I wasn't sure about it, to be honest.
When the pandemic struck, the future was certainly unknown. It was like walking into a blind, dark alley. You didn't know what was there, what was in front of you, what you were going to have to deal with.
It's something that nobody expected. It's something that nobody could plan for.
Rather than your first priority being mission success and getting to the launch pad, your first priority immediately gets displaced, and it's now the safety of the people.
And it took a lot of work to put stuff together in order to keep momentum going, to keep people working safely, keep them healthy, and to keep the project on schedule.
We called the effort Mars 2020 Safe at Work, and the objective was to keep the team as safe or safer than they would be if they were not working. Putting a spacecraft together that's going to Mars and not making a mistake, it's hard no matter what. Trying to do it during the middle of a pandemic, it's a lot harder.
There's no doubt that working in isolation, not virtual isolation, but in physical isolation from everyone else, is a challenge.
It's hard for me. I have 2 young kids, and sometimes I'm not able to focus or listen probably as well as I would want to.
A lot of our work was occurring in a clean room anyways, but that meant that even before we entered the clean room, we had to find ways of ensuring that we were not putting ourselves or others at risk.
We're really doing something that's transformative and trying to understand whether or not life evolved on another planet. That's the fundamental objective of this mission.
We are explorers. Our job is to go into the unknown. And this is just another example of the unknown. How to make this job happen when you're doing it largely through a computer screen.
Pretty much everybody that I've talked to that's associated with the mission has said the same thing, which is you could not have come up with a better name than Perseverance.
I'm a convert now. Perseverance is the right name for the rover.
It's an amazing serendipity that we get to persevere through working on Perseverance.
I think it's a really important symbol of humanity, hopefully persevering through this great challenging time that we have right now.
So you can see it was a challenge for us to overcome this, and we understand that the Mars 2020 community was not the only group facing this. As I said, the community and the country and around the globe, everybody had to deal with this. I asked the team a couple months ago if they would like to do something to kind of symbolize and mark these challenges that we faced, and they designed something that we called a COVID-19 Perseverance plate. This is a plate that's now affixed to the port side of the rover. It has a symbol of a globe representing all of us that face this challenge together, the spacecraft leaving the Earth on its way to Mars, and all of this supported by the now familiar staff and servant of the medical community. The community that was really on the front lines, keeping us safe. And you know, they really inspired us, I think, through this period, and we hope that this plate and we hope that this mission, in some small way, can inspire them in return. You know, this has been a team effort all along. It's a big group of people that's required to do this type of mission. And it's not just the people on the team, but it is the people that support us from the public. And to mark that, we are carrying this plate that you see here. It has 3 microfiche, and those microfiche hold the 11 million names of the people that signed up to take their name along with this spacecraft to Mars. We're very appreciative of that interest and the support that we have. And that's part of what makes this job so exciting. I mentioned the team. As I said, it's a big team, and this is just the team here at JPL that was part of this development. In fact, the team spans every center in the agency pretty much, as well as our international contributors and our tremendous industry partners that have been part of this. Everybody has worked together a lot of days, a lot of nights, a lot of weekends and holidays to get us to the point where we're at. And to kind of tell you a little bit more about the integration and test activity that's been happening down at Kennedy Space Center and the final steps to get us to the pad, I'm going to hand it off to Luis Dominguez.
Great. Thanks, Matt. So the Assembly Test and Launch Operations Team, also known as the ATLO team, started assembly of the spacecraft back at JPL in January of 2018. The ATLO team is the team on the project that's entrusted with putting together the final flight vehicle, and we take components from across JPL, the US, and the world, and we start populating that onto the spacecraft and testing them to make sure that everything works properly. We're talking about the radio, the flight computer, control boxes, antennas, lasers, all the different instruments that allow the spacecraft to do its mission once it gets to Mars. When we initially shipped to KSC, the spacecraft was actually shipped in pieces. So all the individual stages of the spacecraft were shipped independently: the crew stage, the descent stage, the rover stage, the back shell, and the heat shield. And when we arrived, we did a lot of testing to make sure that nothing was damaged in transportation and that everything was working appropriately. And then we began to assemble the spacecraft for the last time. As the Deputy Electrical and Integration and Test Lead for the team, my main focus is on integrating all the electrical and electromechanical components of the spacecraft while making sure that the personnel and the hardware are kept as safe as possible during that integration process. We also, you know, it's a highly stressful, highly demanding environment, but it's also extremely rewarding to see the spacecraft put together like that. At the moment, we're currently in the process of electrically integrating the harness that connects the spacecraft to the last stage of the launch vehicle, which was just installed last night, actually. And as soon as I'm done here, I'm going to head into the high bay to start checking that out. And after that's complete, we will begin encapsulation of the spacecraft. And the encapsulation of the spacecraft is where we actually clamshell the spacecraft in between its two payload fairings, which will protect it while it's exiting Earth's orbit and on its way to Mars. As you can see, the spacecraft is a very small part of this launch vehicle, but it's the most important part, and we're hoping she gets there safe.
Thanks, Luis. And I actually have a couple questions for you. What else is left for your team to complete on the Perseverance rover?
So once the spacecraft is encapsulated, we will actually lift the spacecraft onto a transport vehicle And then that transport vehicle will take it to the vertical integration fixture facility, where it'll get craned to the top of the rocket and mechanically integrated. And we'll do some final electrical closeouts before we light the candle.
That's great. And I also heard you started as an intern for the Curiosity rover. So what's it like to see your work on this next generation rover as it gets to the launch pad?
It's been an amazing adventure here at NASA. I started as an intern on the ATLO team, actually, for the Mars Science Laboratory project. And it was interesting moving from more smaller day-to-day, week-to-week tasks when I was a student to being a lead on this very important mission and taking a much more strategic, big picture view of integrating a spacecraft. I can actually say I've touched and tested in some form every piece of hardware on this spacecraft. And I truly appreciate the work NASA does to provide internships to students around the country, and thankful every day for having been given that opportunity. Having grown up in South Central Los Angeles, I never thought I would be where I'm at today. And it's an honor and a privilege to work with all the brilliant people on this team at JPL and at NASA. I'm really looking forward to launch day.
Thank you, Luis. Thank you for answering my questions. And hitching a ride on the Perseverance rover is the Mars helicopter, which now has a new name, Ingenuity. Ingenuity will attempt to be the first powered flight on another planet. Mars helicopter project manager Mimi Ung has an update on this exciting new technology experiment.
At this time, Mars helicopter Ingenuity is fully integrated on the rover. The helicopter is stowed under the belly pan of the rover and has been checked out to be fully operational in the configuration that is going to be launched and operated in space. Our team is now preparing for operation after launch, updating our simulations and rehearsing for the scenarios that we're going to encounter. Starting with monitoring the health of the vehicle through the cruise to Mars, when the rover deploys the helicopter, and commissioning of the helicopter, all the way to our very first rotorcraft flight attempt at Mars. Seeing our helicopter get launched is the start of everything our team has worked for, and after it lands, it's going to be extraordinary. After all of us working really hard for over 6 years, it's going to be outstanding to get to attempt the very first rotorcraft flight test at Mars. And in fact, first time on any other planet outside of our own Earth.
Both Perseverance and Ingenuity are riding on the same rocket to Mars. Right now, NASA Launch Director Omar Bias joins us with an update.
Hello there. Hello from Florida. So we're 34 days from launch, and the things that are going on have been touched on here. The spacecraft will undergo encapsulation, as Luis says, into the clamshell or the fairing halves in the coming weeks. The launch vehicle, if they could roll the tape. This is actually the rover coming in, and this is misleading because that rover, that's one piece of it. There was 16 tractor trailers that came in with other equipment. There was another flight for other pieces. So it did not just fit in that box. There's a lot more that went into this mission, and the assembly started in January back here. This is actually the Atlas booster being offloaded from the Antonov airplane that brings it in from Decatur, Alabama, where the booster is built. The booster provides the first 4 minutes and 20 seconds of power for the flight before the Centaur, the upper stage, it takes over and puts us into its final escape orbit from the Earth to Mars. Along with the first stage booster are 4 solid rocket motors, which you see being assembled here. Those will burn for approximately 1 minute and 50 seconds, providing the initial boost to get that complete stack of the first stage, and the upper stage, Curiosity, the payload fairing, to its C3 velocity, the escape velocity of 14.4 kilometers square second square for those that need preciseness. That'll get us on its way. We're looking forward to July 20th for that 9:15 time to get them going, and so that the booster can do its descent and landing into Mars in February. From behalf of the launch services program here at KSC, we look forward to it. We're looking forward to fueling the vehicle this coming Monday as part of our wet dress rehearsal. And after that, we will be putting that encapsulated assembly of the spacecraft and the fairing on top of the booster, and doing the final preparations for installation of the power source that'll power the rover for years to come. So from behalf of NASA and the Launch Services Program, it's a pleasure to do this launch, and 34 days from now, we'll have some happy faces here.
Thanks for the update, Omar. We're looking forward to the happy faces. Now, we are ready to take media questions. Remember to press *1 to get put in the queue, and please direct your questions to one of the panelists. We're also going to take questions through the Ask NASA hashtag, but first on the phone line is Bill Harwood from CBS News.
Oh, thank you very much, and I appreciate this, guys, for taking the time to chat with us. Two very quick questions. One is just to have an update, maybe for Lori. What is the total cost of this mission, or what number should we be using? And maybe for Omar, how much, and for Matt Wallace, how much reserve is left in the schedule to handle anything that goes out of the ordinary? Are you right down to the wire, or have you got some time to handle unexpected issues? Thanks.
Great. So thanks for the question. So I can tell you that the cost for the development of the Perseverance rover all the way up through launch is about $2.4 billion, and then there's another $300 million that we'll spend to operate Perseverance after it's launched and it's on its way, and then once it lands, and to do all of the surface science once it gets to Mars. I'll toss it back over to Omar and to Matt.
Yeah, I'll just say,
Okay. And as
relative to the spacecraft, the key margin that we have is in the launch window itself. We're targeting the first launch day as July 20th, as Omar said, but the window, in fact, lasts until August 11th, and so. And even during those single days, we have multiple opportunities to recycle if there's some issues. And so we think we have some robustness there. We have good robustness there in the launch window. Relative to the launch vehicle processing, I'll turn it back over to Omar.
And yeah, Bill, relative to schedule, we are a green light schedule from here on out. In other words, any major perturbation could affect the launch date. But as Matt said, we got plenty of window or runway ahead of us, and we're not worried about it. I'm sure, Florida weather as it is, it's been perfect the last couple of days, but we'll probably run into some not so perfect days that could set us back. And the team is flexible enough to be able to handle a 3-week window. I would say, and we have analyzed out to the 11th of August, and if need be, and the analysis provides us additional margin, we might even get out to the 15th of August. So no concerns from our part.
Great. And now the next question is for Maria Corin from The Atlantic.
Hi, everyone. This question is for whoever would like to take it. There are some scientists and other space fans out there who think that NASA has given a lot of attention to robotic missions to Mars over the years, and they want to see spacecraft visit other spots in the solar system, especially moons where there might be evidence of life right now rather than ancient signs. So I'm wondering what you would say to those people who believe that Mars is a little bit overstudied and that we should be focusing elsewhere in the solar system on the search for life.
I'll be happy to take that question, Maria. Thank you. I'll take it. Yeah, I, for one, am a fan of our entire solar system. I love every destination that we have. There's incredible science across, as you know, the entire solar system. Mars has been a really fantastic place to really explore in depth. And so our Mars exploration program has really done an amazing job at Mars, and there's still a lot of work to be done there. But I absolutely agree with you that there are other places in the solar system that might actually be maybe even better places to be looking for actual extant life that might be present today. And of course, the moons of Jupiter and Saturn, for Europa or Enceladus or maybe even Titan are places where we feel like there may actually be environments that could be conducive to having life today. For example, on Europa and Enceladus that are covered in ice, certainly there is probably low probability of life on the surface, but beneath that ice, we believe there are these deep oceans that may have thermal sources at the base of those that are driven by geologic processes that recycle the oceans and recycle the nutrients within those waters, and could actually be sites where we think you have all the ingredients necessary for life. And so we are looking for great ideas to send other missions. We've got Europa Clipper that's going to be going to Europa to map the surface. It's an orbiting mission that'll orbit Jupiter and make several passes of Europa. That'll launch later in this decade. And now we're also developing the mission Dragonfly, which will launch in 2026 to go to Titan and to explore the environments there on the surface. That's actually the next rotorcraft that will fly in a planetary atmosphere, is an octocopter that will land on the surface of Titan. So those are also excellent destinations, and we're very interested in them and pursuing a variety of different ways to get there.
Thanks, Lori. And up next on the phone lines is Marcia Dunn with AP.
Yes, hello, thank you. I have some questions about the return samples. The animation almost makes it look like the cylinders with samples are just sort of dropped on the surface of Mars, sort of scattered. How are you going to leave these samples for pickup? Do they have beacons in case there's a dust storm of some sort? And also, maybe for Dr. Glaze, why 10 years to get the samples back? I would think, I know you want them as soon as possible, and waiting a decade just seems like a long time. So if you could answer that, that'd be swell. Thanks.
I was going to suggest that perhaps Katie take the first part, or Matt.
Yeah, I can start off, and Katie can jump in here. Just to understand how these samples are collected and then left on the surface. We do collect them as individual tubes, and we have the ability to drop those tubes either in ones and twos or in groups. Our current intent is to drop them in a grouping so that the fetch rover, which you saw in the animation, would not have to go to many locations to actually pick those tubes up. And so we have complete flexibility, but that would be the intent. As far as the dust storms go, we know how the sand and the dust moves on Mars, and we know what locations to select to make sure these are not affected by those types of issues. And so we don't think there's going to be any issue with respect to covering up the tubes over the period of time that we're talking about, or finding the tubes on the surface. And Katie can say a word or two maybe about the sort of science strategy associated with that.
Yeah, that's something that we are still very much thinking about, and will be guided by our exploration on the surface as we, decide where and how to sample, and where we'd like to leave that sample cache. I think it's important to think about what samples go in what cache and where as the fetch rover capabilities develop and Mars sample return architecture develops as well. So we'll be thinking about that, and that'll probably be an active iterative conversation that we have with the Mars 2020 project as well as the Mars sample return architecture as it develops.
Great. Yeah, so I'll now try to take the next part of that question, which is, why does it take so long to actually get the samples back? And you're absolutely right. We definitely want to try and get those samples back here. They're very precious. We want to get them back here so that we can start the analysis and learn from the samples. But this is a really complex concept to try and bring those samples back. And in fact, we've always known from the very beginning that this was not going to be a simple mission where we simply fly to Mars, collect the samples, and bring them back. We've always known it was going to require multiple steps and multiple launches in order to actually get the samples back, not only because of the time required, but the cost as well. So we need to pace that out. We're really in a great position right now where we have developed a fantastic partnership with the European Space Agency, which actually allows us to get those samples back a little bit earlier than had originally been planned if we were trying to do it all on our own. By collaborating with ESA, it allows us to have 2 launchers from Earth, a European launch and a NASA launch, that will send the Mars sample return mission out to Mars, collect the samples, and bring them back, like the animation that you saw. Allows us to do that in a shorter time period. Right now, we're working on and developing the plans for that Mars sample return mission. We're planning towards a launch around 2026, which would then bring those samples back in 2031. It takes a little time to get out there. It takes time to pick up the samples on the surface. Then it takes time to actually get out of orbit at Mars and bring them back. So it's a long and involved process, but it's one we're absolutely dedicated to, and we're going to make it happen.
Great. That was some great teamwork getting that question answered. Thank you. And on the line now we have Keith Cohen with NASA Watch.
Hi, I have a question for Jim Bridenstine. It's a branding question. You just brought back the worm logo. So Bobby Brown was recently on 60 Minutes, and he referred to this mission as NASA's first astrobiology mission. Now, of course, the Vikings were, but I'll let Bobby add that. But NASA has a program that's been going on for 20 years, and it's called astrobiology. Yet if you go to the website for this mission, unless you know where the one page is where it mentions astrobiology, there's no links, no nothing. You go to the astrobiology page, they don't even know this thing is happening today. They don't even mention the rover. And so I'm kind of wondering, there are going to be 4 rovers on Mars soon, all doing astrobiology, and it's going to be a big deal. So maybe you could explain a little bit on the branding and the marketing here, why NASA can't get their act together, and maybe, hoping to hear that you're going to get this all figured out by the time the thing lands.
No, Keith, that's a great question and a great point. I'll tell you, astrobiology is really something that it depends how you define it, whether or not this is the first mission or not. If you look at what we did with Spirit and Opportunity, we made discoveries. We discovered that on the northern hemisphere of Mars, it was 2/3 covered with water. That indicates that it had a very thick atmosphere, that it had maybe even a strong magnetosphere, which would indicate that Mars at one time had a molten core. When we think about having a thick atmosphere and liquid water on the surface and a magnetosphere, all of that indicates that Mars was maybe at one time habitable. In other words, it could have supported life. So you could argue that even when we were doing Spirit and Opportunity, that those missions were astrobiology missions. And of course, with Curiosity and now Perseverance, we're building on that base of knowledge. And so all of that is so important. We are, in fact, trying to find signatures of life. And of course, we're interested in finding life itself. Now, that's not what this mission specifically is all about, but I can tell you, in the last couple of years, NASA has made some significant discoveries. Complex organic compounds on the surface of Mars, methane cycles that match the seasons of Mars, liquid water 12 kilometers under the surface of Mars. So there's so many things that are kind of building up here to say that, look, the probability of finding life on another world is going up. We're not saying it's there. I don't know that it's there. Nobody else knows either. But that's really what astrobiology is all about. And Mars really gives us the best opportunity, I think, in the short term to make a significant discovery that will forever change how we think of ourselves and forever change how we think of space exploration in general. Look, if we can find life on another world, I think people are going to be so excited about the discovery and what comes next. That we're going to be doing missions throughout the solar system. I know that the question earlier about why are we going to Mars and not these other places, certainly we want to go to all those places, and we have plans to go to all those places. But it's also true that the highest probability of maybe finding life at this point is going to be Mars. There are people out there who would say that Europa or Enceladus provide biologically a higher probability. but technologically, that's going to take some more time. And of course, working on that. JPL, I want to give a lot of kudos, a lot of compliments to JPL, which is, a partner with NASA. We call it one of NASA's centers. Of course, it's affiliated with Caltech. But what an amazing job by that team. And of course, they're building the plans and the hardware that's going to help us get to Europa, that moon of Jupiter, where we believe there's the ingredients that could potentially have life. So there's a lot of exciting things in the field of astrobiology. And, 15 years ago, even 10 years ago, if you would have said these things, people would have looked at you like you're crazy. And now it's starting to become more and more real. So it's a great question. It's a great point, and it's something NASA thinks about all the time.
Great. Thanks, Jim. And we've been getting some questions coming in through the Ask NASA hashtag. I'm going to read one of them now. Aaron on Twitter is asking, apart from entry, descent, and landing, what is the most challenging part of the mission?
Well, I can try to answer that question. There's a lot to choose from. These missions are very, very difficult. We talked about the challenge just in the last few months, dealing with the pandemic, obviously. But I think from a basic mission perspective, the most difficult part has been building and testing the sampling system that we referred to. As I said before, it's composed of a lot of different mechanisms. These are systems that have to operate at a very high level of reliability. They have to operate autonomously. There's a lot of control and autonomy in our software systems that go along with them. They require extensive test facilities so that we can simulate the Martian environment and the right set of rocks and targets. And then, of course, on this mission in particular, because of the search for those very faint biosignatures, which Katie and other people talked about, we had to keep them essentially sterile from a biological perspective and exceptionally clean, especially organically clean, which are the signatures, the chemical signatures we're most interested in. So that's a difficult thing to do. When the rest of your spacecraft is really designed and inherited from the systems that we have to use in the aerospace industry and in civil space. So we had to isolate a lot of the key critical components from the other parts of the spacecraft from a contamination perspective. And that was, I think, the biggest challenge for this mission.
Once we get on the surface of Mars, we have a responsibility to put together a cache of samples that is compelling enough and worthy enough to return to Earth, and interesting enough that it will propel and drive future generations of Mars science and planetary science. And we take that responsibility very seriously, and we know that we have a tough job to do on the surface to put that sample cache together. And so I think that's going to be a challenge that we have to put together diverse samples, those that have potential biosignatures, and enough samples that we cover the ground to get that job done. So we take that very seriously, and I think that's going to be a big challenge for our team once we get on Mars.
Thanks, Katie. And Matt, you kind of touched on this. Naz on Twitter is asking, is there any level of autonomy included on this Mars rover?
There's a lot of autonomy. Again, just starting with the entry, descent, and landing activity, one-way light time to Mars is about 10 minutes. And from the time we hit the outer atmosphere of Mars to the time we're safely on the ground, it's about 7 minutes. We refer to it as the 7 minutes of terror. There is absolutely no interaction with the spacecraft during that period of time. It has to do that entire process itself. It has to understand, where it is from a navigation perspective. It has to know when to jettison the cruise stage and deploy the parachute. It has to understand where it is in Jezero. I talked about this terrain relative navigation system. This is really, again, another level of autonomy that we're laying on top of our historical autonomy on these missions. And this is a feed-forward capability that these future human missions, as well as the sample return mission, which Lori talked about, will need and will want to use. Trying to understand where those hazards are and divert away from them, all of that requires the spacecraft to understand, to do those things on its own. And that's before we even get to the surface. Once we're on the surface, we really are only able to command the vehicle once a day. And so it'll sleep and conserve power overnight. It'll wake up in the morning. We'll send a sequence of commands, give it its daily set of activities to do. And then it has to carry them out pretty much by itself. It has to make the decisions on how to drive to the target and how to do a lot of that sampling work that we talked about, as well as keeping itself safe under adverse anomalous conditions. And so there's a tremendous amount of autonomy in the vehicles, and it's one of the things that makes the system so complex.
Thanks, Matt. I'm going to head back to the phone lines now. We have Gina Sunsuri from ABC.
My question's been asked and answered. Thank you.
Great. Thanks, Gina. All right, we'll go next to Mike Wall from space.com.
Thank you all for doing this. This one's probably for actually Matt, and it's just about the helicopter. And I'd just like a few details maybe about what you would consider mission success for the helicopter. Like, how many flights do you hope to make? How far will those flights be? And also, is there a possibility that we'll get kind of Perseverance eye views of the helicopter going up and exploring Mars skies? Because that would be pretty fantastic if you can pull that off. Thank you.
Sure, I'll say a few words about the helicopter, in that this is really something that's cutting edge. This is, as the administrator said, something that's never been attempted before. And flying in Martian atmospheric conditions, which, the atmosphere on Mars is only 1% the density that we have here on the Earth, and trying to control a system like this under those conditions is not easy in flight. And then you have to land it safely in an unknown terrain. These are all big challenges, and that's why this is a technology demonstration payload. This is something that that we're taking with us so that we can learn how to do this for future missions. And so that's really the objective, is to get the helicopter. Just to be able to accommodate it on the vehicle was a big step. Getting it to Mars, getting it safely off the vehicle, we're going to learn a lot. And really just the very first flight, where this helicopter spins its rotors and lifts up off the ground, it's going to be both historic and we're going to learn a lot. And so we are not, we are not looking for an extensive and ambitious return from this technology. We're looking to learn those first few things that we need to learn with the technology. We should be able to image the helicopter while it's flying from the rover. We're going to have a safe standoff distance, 50 to 100 meters or so. But we have pretty powerful cameras that we should be able to zoom in, and we're hoping to be able to catch that flight. Whether or not the helicopter will actually see the vehicle, the Perseverance rover, will depend a little bit on orientation and how high it goes and those sorts of things.
Great. Thanks, Matt. And now on the line, we have Lauren Gersh from The Verge.
Hi, thank you so much for taking my question. I think this is for Katie, possibly. Seeing as how Perseverance is all about deciding whether or not Mars has had past life, I'm curious to know what you are considering a biosignature and how you will make the distinction whether or not you have actually found evidence of past life on Mars. Thanks.
Yes, thank you. That's a great question, and it's one that we think a lot about on the science team. I think our bar is high for the identification of a sign of life on another planet, as it should be, because we don't want to make that discovery lightly. But at the same time, with Perseverance and its goal of seeking signs of ancient life, I think we also have to open our minds to the possibilities of what life could look like on another planet, and looking for examples of something that is similar to what we see in biosignatures on our own Earth record. And so I think what we're looking for are really the patterns and textures where we have a hard time explaining how that could have formed without the influence of life. And I think every time we see something on the surface of Mars that kind of gets lets us asking those questions. We go through the list of possibilities. Could it have formed in an abiotic way? And I think if we get to the point where we are really struggling to explain a phenomenon or something that we see with abiotic processes, I think that's when we start to say, I think this could be a potential biosignature. But I think it's also important to realize that very likely we'll have to return those samples to Earth to make that definitive conclusion about whether these samples contain life in them. So I think on the Perseverance side, we see it as our job to identify potential biosignatures, things that are worthy of additional study here on Earth with the full arsenal of analytical capabilities that we have here in our own laboratories. And I think that's how we're going to approach that question on the surface of Mars.
Great. And up next, we have Antonia Jaramillo with Florida Today.
Hi, thanks for taking my question. I was just wondering, as cases of coronavirus in Florida continue to rise, will NASA be asking the public again to watch this launch from home? And if so, will it also provide a virtual experience show like it did for Demo 2? Thanks.
So for this particular mission, we're asking people to follow the guidelines of the governor of Florida. We want everybody to practice social distancing, and if you're within 6 feet, make sure you're wearing a mask. Those kind of things. But we're not telling people not to visit for this launch. We're not saying that. What we do have to make sure we do is we protect the workforce at the Kennedy Space Center, because we have a lot of work ahead of us, especially this summer. We've got the entry, descent, and landing of the Crew Dragon that took our astronauts to the International Space Station. We have just a lot of other activities. We have to make sure. So we're not going to open up the Kennedy Space Center, but certainly people are going to travel. We ask people not to travel for DM2. Which was, of course, the launch of the Falcon 9 rocket with the Crew Dragon and Doug Hurley and Bob Behnken in the capsule. And it appears they didn't listen to us. So we're asking people to follow all of the necessary guidelines to keep themselves safe, and we're trusting them.
Thanks, Jim. Up next is Dave Mosier with Business Insider.
Thank you for taking my question, and good luck with the launch. Matt, you mentioned the EDL video cameras. I'd like to know more about those. What resolution will they film in? When might we expect that 7 minutes of terror footage to get back to Earth? And will you have any use for them after landing? And then I also understand that this is a discretionary payload. Did these cameras sort of beat out any other ideas that the team had? Thank you.
Yeah, those are all good questions. I'll try to answer them in some sort of order. But just to start with your last question, these were not in competition with any other payload on the spacecraft. Our payloads were selected via the normal process, and as we got further down the road and got more mature, we realized that we had an opportunity. We had some residual capability to install these. They take very, very little mass and volume. I don't have the numbers exactly, but they're essentially unnoticeable at the spacecraft level as far as resource requirements go, and that's because we didn't build something new. We didn't build something that was particularly sophisticated. We were able to go out and use commercial, off-the-shelf, available products, and so that made it a lot easier to go both develop them quickly at low cost and to accommodate them. Resolution-wise, I'll have to check. I believe there are 10 megapixel cameras, frame rates as high as 40, I think, frames per second. But we can get the exact numbers. They produce a lot of data. The data is not going to come back in real time during entry, descent, and landing. We have very limited telemetry during that period, and so we'll bring that imagery back over the first couple weeks on the surface.
Thanks, Matt. Up next is Paul Brinkman with UPI.
Yes, hello, thanks for doing this.
Obviously, the Mars rovers have surprised in the past in terms of how long they've stayed operational. I'm wondering, what is the outside length of time that both Perseverance and Ingenuity could be operational, and also regarding the helicopter, to what extent do you know like how many flights there might be for that? Thanks.
So I can respond to the longevity question. We have a primary mission defined for the vehicle of 1 Mars year, which is roughly, two Earth years, and that's similar to the design requirement for Curiosity. As you know, Curiosity is still operating on the surface here, about 8 years or so since we landed. The good news about these systems is that although they have to operate in a harsh environment, that environment is relatively repeatable and stable. And so once you get past those initial issues, those infant mortality issues, it's not unusual for our spacecraft to continue on for well beyond their design lifetime. Voyager 1 and 2 are the best examples I can think of, but there's no guarantee, and so we try to operate the system under the assumption that that we'll only have so much time to get the work done, and build it robustly, and hope that we get more time.
Great. Does anyone want to take on the Ingenuity question?
On Ingenuity, we have 3 flights designed for the surface. I think kind of nominally. However, as I said, we're going to take them 1 flight at a time. So.
And then up next is Tony Rice with WRAL.
Thanks for taking my question. This is from Matt Wallace. One of the few disappointments from the Curiosity entry, descent, and landing was the damage that occurred to the wind sensor on the REMS instrument. Have there been any changes in the EDL procedure or in the META instrument itself to prevent something similar from happening again, based on what you learned nearly 8 years ago?
Yeah, one of the things we learned with our Sky Crane system is that we have the ability to kick up some debris from the engines on the descent stage, and we have taken have made some changes on this project to protect things that are sensitive to that or potentially sensitive to that. Optics, wind sensors are good examples. We have a debris shield, for instance, around the helicopter on the bottom of the vehicle. So the answer is yes. We've tried to adjust for that environment.
Great. Thanks again, Matt. We have a lot of people on the lines right now. Up next is Lee Holtz with the Wall Street Journal.
Hi. Thank you very much for taking a question. For the administrator, if I may, NASA is not alone in voyaging to Mars this summer. China expects to launch its first Mars lander, I guess. The United Arab Emirates is launching its first interplanetary mission, Destination Mars. The European Space Agency and Russia are putting their lander together for 2022 now, I guess. And, of course, SpaceX keeps talking about starting the cache supplies for future colonists. I mean, this is very busy. I wonder if you'd reflect for us on the changing nature of interplanetary exploration in this age of internationalization. What are the operational and diplomatic effects from your vantage? Thank you.
Well, that's another very important question. The first thing that we're going to need is additional communication throughput. That's the number one thing that we're going to need, and we're already at the limits of our communication capabilities for deep space. So we're going to need to really plus up the architecture for that. But to your point, a lot of these countries that do these activities, they want to use the deep space network that NASA has established, and we're very willing to support in that effort. This is about science and discovery, exploration, and And I think when people see countries doing these stunning things on other worlds, it inspires all of us. And so certainly we are supportive of these activities. And ultimately, remember what we're trying to do. We're trying to get humans to Mars. That's the objective. And these robotic precursor missions, I think, kind of open the eyes of the American people and people all around the world as to what the possibilities are, and it helps inspire that next generation. In fact, maybe even our generation, where we see humans living and working on the surface of Mars. So there's a lot that goes into this. I'm very excited about the United Arab Emirates and their HOPE mission. We have done a lot to support them, and they want to be big supporters of ours in the Artemis program. And of course, they're very involved in, they're going to be launching in a few short years their own rover to the surface of the moon. So a lot of countries are stepping up in a big way. Countries that historically have not been, exploration countries are stepping up and not just talking about it, but backing it up with budgets. And so all of this is going to be very helpful for us as we move forward. NASA is an institution that is a tool of diplomacy, and there is no better diplomacy than exploring our own solar system together and eventually the rest of our galaxy and universe.
Great. Thanks, Jim. And now we have Chris and Carlo with KFI News.
Yeah, thanks, guys, for taking my question. Just going back to COVID here real quick, some specific challenges you guys obviously faced in working remotely. NASA and JPL are a bit famous for adapting and building out new systems for those adaptations. And I'm just curious about what adaptations to workflow may be carried forward in the future. What lessons did you learn during the shutdown?
I'll start. There's so many different things. As right now, most of NASA is working remotely. NASA has been for a long time very forward-leaning on teleworking, and so it was really easy for us to actually go to a profile where most of us are working remotely. So that really was not terribly problematic. At the same time, we still have to build hardware, and our contractors still have to build hardware. So we have to make sure that we're doing what we can for social distancing, changing shifts so that instead of having 12 people working on a vehicle at the same time, we could divide it up, and instead have 8-hour shifts where you've got 3 shifts of 4 people working on a vehicle, and of course making sure everybody has their personal protective equipment and those kind of things. As we move forward, as we start going, we went all the way to stage 4 at a lot of our centers, which meant basically nobody can come to work because you look at some of our centers, there were some outbreaks of coronavirus in the regions where those centers are. But now we're getting to a point where we can go to stage 3, where we have mission critical, not mission essential, which is what Mars 2020 is, but mission critical functions, which are still very important missions that we need to start getting back underway. And eventually we want to get back to stage 2 and eventually back to a normal working environment. But I think one of the things that we've taken away is how much work you can actually do when you're still at home. So there's different types of work that you're able to do from home. And I'll tell you, when I'm at home, I'm doing a lot more outreach than I've ever been able to do before because everybody is either a phone call or a teleconference away. We're not having to organize schedules to get everybody's schedules to perfectly match and travel and everything else. So there's certain areas where you're more productive and other areas where you're less productive. And I think when we get back to a more normalized work environment, we're going to have to take the lessons learned and apply them. And I know JPL has been thinking about these things as well. So I don't know if anybody else has anything to add.
Yeah, I mean, I'll just agree with the administrator completely. We're carrying these lessons forward. We're starting to look as well into at least relative to 2020. We're pulling the lessons learned that we've acquired over the last several months into our operations. We're thinking about what it means with respect to critical activities like entry, descent, and landing. And we're getting a lot better at every day, really, I think, at operating remotely and understanding how to safely bring people in to get the work done, as was discussed.
Right. Thank you. And next on the line is Jennifer Lerman with Popular Mechanics.
Hi, thank you so much for taking these questions. A quick question for maybe either Matt or Katie. What do you hope to learn by recording sound during the mission? And then Katie, actually, another very quick question. You mentioned that you were a little bit iffy about the name Perseverance. Was there another name that you also favored, perhaps? Thank you again.
Yeah, maybe I'll start off. And to your first question, what we hope to use the microphones for, I think we're really excited to hear the sounds of Mars and the sounds of the rover interacting with its environment. We'll hear the wheels whir and the gears turning, and we have a microphone on the SuperCam instrument. So when we basically zap the rocks with the SuperCam laser, we'll hear that zip sound, and that may tell us something about the properties of the rocks themselves. So there may be some science to glean from that as well. So we're excited to use the rover's ears to do that. In terms of the rover names, there were 9 candidates there, and I think everybody had their favorite. I don't know that I had a particular favorite there. But in the end, the rover name when the rover name is selected, it just really becomes part of the rover. And once that name is selected, you can't separate the rover from its name. And so, I think those of us who've worked on some previous rover missions, it just happens. And once the name is selected, it just becomes. And so I think that's very much what's happened with Perseverance for me personally. And I know that that's true for everyone else too. So it is Perseverance, and we're excited that it is.
Great, thank you. And up next is Leo Enright with Irish Television.
Thanks, Raquel. I think this is probably for Katie, who talked about the complexity of collecting samples on the surface. The actor Matt Damon famously scienced the you-know-what out of Mars, and we can certainly say that the Curiosity rover has done that at Gale Crater. But it does seem like the traverse there has been far, far slower than most people would have expected, for very good reasons. Yellowknife alone would delay you for months. But I'm just wondering, will there be different time pressures on this mission at each sample site, just to get the sample and move on to the next, to collect enough for the return cache? Will it be more of a shoot and scoot mission?
Yeah, so that's a great question, and one that we are thinking a lot about as we come up with notional scenarios for the mission and what our sample cache might look like. One thing that we know about that sample cache is that we wanted to have diversity, and we wanted to cover the interval of time that we think the rocks in Jezero represent, and that does require us covering substantial ground to put a cache together like that. But I think we have a couple of advantages on our side, particularly in comparison to Curiosity and Gale Crater. Part of the reason we picked Jezero Crater as a landing site was because it had such a well-understood environment that we could see and understand from orbital images alone. And so in Curiosity's case, in Gale Crater, you have a 5-kilometer thick mound, and uncertainty of what that mound actually represents geologically. So we've had to spend a lot of time with that mission doing the science to understand what rocks we're even looking at. With Jezero, we know already that we have a delta. We know that we had a lake in Jezero Crater, and we know that this crater is perched on the rim of a giant impact basin. So we expect things like impact megabreccia, sampling some of that ancient Noachian crust on Mars. So I think the fact that we have such a good understanding of this landing site already really helps us plan and plot out the course of our sampling exploration. So I think that really helps us. And so I think we will feel some pressure to cover that ground simply because we want to put together the best cache of samples that we can. But we have some advantages, I think, over some previous missions in terms of how well we understand our landing site already.
Great. One more question from Aklo Jha from The Economist.
Hi there. Can you hear me? I've got a really quick question for the scientists. Probably Dr. Morgan. And then another one as well. But the first one, you talk about how this mission is the very latest in the sort of the long quest to try and answer the question of whether there was life at one point on Mars. I just wonder if you could describe just briefly what is it about Perseverance that what will it be able to do that previous missions possibly haven't to get us closer to answering that question? Because from my understanding, if life is there, it's not that this will detect it, but they'll be able to get much, much closer to that answer. And the other question I just had quickly for the group as well was, we know there's plenty of missions going to Mars, and the UAE one, as we've heard, and the European Space Agency eventually. Can you just talk a little bit about how your science on this mission will complement the science going on elsewhere? I know you're talking, but it'd be interesting to know how you're complementing each other.
Yeah, so I'll tackle your first question, and that's where I think we really get to some of the instruments and the scientific payload that we have on Perseverance. And those instruments on the end of the rover's arm that have the ability to map in very fine detail chemical composition, mineralogy, and the presence of organic carbon in a way that we've never been able to do before. As you may know, Curiosity has the ability to detect organic carbon, and it has detected organic carbon, but we haven't been able to necessarily link the presence of that carbon, organic carbon and organics, to particular textures or patterns that we see in the rock that we think could have been left behind by life. And so it's really that connection of the textures and the composition that allow us to make a compelling case for a biosignature. And the instruments on Perseverance allow us to do that really for the first time on the surface of Mars in a non-destructive way. Also in the way that we collect our samples. Instead of grinding the rocks into powders, we're actually collecting preserved cores of rock that we can bring back to Earth and study. So I think that's really how we distinguish ourselves in advancing the search for potential biosignatures on the planet Mars. And maybe I'll toss it to Lori or someone else in the panel to answer the second part.
Yeah, I'm happy to take the second part of that question. Thanks. So yes, as you mentioned, there will be several missions headed to Mars, several this summer, and then of course European Space Agency in 2 years as they postpone the launch of the ExoMars rover. But this summer, of course, China's going to be sending their first lander to Mars. We're all going to be watching that very, very carefully. This is an incredibly difficult thing to do, to land safely on Mars. We know how challenging it is. We've had our own struggles in the past. We've been very lucky and learned a lot from those, and are, we've been successful the last several times. So I have full confidence in our team this year. But it'll be interesting to watch as China attempts this as well. So that'll be an interesting thing to watch. The United Arab Emirates, of course, are sending their orbiter, the HOPE orbiter. This will be their first foray really into this interplanetary flight. So trying to build something that can do science in orbit around Mars, I think will be very complementary to the other orbital missions that we already have at Mars as well, to complement those activities. And then, of course, the European ExoMars rover, when it arrives, is very complementary to what Perseverance will be doing on the surface. One of the things that the ExoMars rover will be doing that is a little different than what we're doing with Perseverance is it has the capability to actually drill a couple meters below the surface to pull up a sample. And this is really important because the samples at the surface have been exposed to radiation, and if there were actually life present on Mars at the surface, it may have been destroyed through that radiation. But samples beneath the surface may actually still have a potential to contain some actual extant life. So there's going to be a very interesting complementarity there between the ExoMars rover and Perseverance.
Great. Thank you, Lori. And unfortunately, we can't answer all the media questions on air. For those of you with additional questions, please call JPL's Digital News and Media Office, and we'll also continue to answer questions of social media online right now. So thank you for your questions, and thank you to our panelists for joining us today. Perseverance is targeted to launch from Cape Canaveral, Florida on July 20th. It will land on Mars in February of 2021. You can follow at NASA Persevere to keep up with its launch and journey to the Red Planet. And join our conversation by using the hashtag #CountdownToMars. You can also visit nasa.gov/perseverance and mars.nasa.gov/perseverance. For all of those interested in a deeper dive, we also have a new press kit available online, and it is filled with information and graphics describing the rover and mission and can help answer any questions you might have. All of the images you saw today will replay after this briefing. Thanks for watching.